compare a Mercury Vapour light performance with a LED light. This is a 200 watt LED high bay. This is a 400 watt Mercury Vapour high bay light. They're two completely different. As you can see, you've got a large bulb and you've got the LED chips. What we want to compare is the dropout voltage and show you the performance of what happens during a brownout and a blackout, and how that will affect the performance of the two different lights and how they'll perform. So what we'll do is we'll just watch the voltage here, which will be the voltage of the incoming AC power. Now we'll wind that up now. As you can see, I'm winding that up now to 240 volts, close to 240, and now I'm going to turn both lights on. Now it'll get very bright, Wes. Now you can see the LED light came on instantaneously. The Mercury Vapour light takes a long while to start. It has a ballast, and it has a long starting characteristic due to the arc has to strike and stabilise. So as you notice, the LED is bright immediately, instantaneous, just like that. So this is taking a long while to start. It's making a lot of noise, and of course it's using a lot of power. This light is using around probably about 210 watts of power. This light here is probably using around about 450 watts of power. The voltage at the moment is about 237, which is the voltage feeding both lights, so that's well within tolerance of the mains power. We'll just wait for this Mercury Vapour light to come up to full brightness. Once it comes up to full brightness, then what I want to do is wind the voltage down and show you the dropout characteristic. It's still coming up to full brightness at the moment. It's still coming up to full brightness at the moment. As you can see, this is a completely different characteristic. This has a standard type of reflector. This has what we call a prismatic reflector. This has a glass protection. So they're two completely different types of lights. Now we're approaching the lighting. We're approaching stability now. It's coming up, and you can hear the ballast of the old Mercury Vapour light is starting to quieten down. Now I'm going to run the voltage down. So if you can see here, the voltage is going down, the voltage is going down, the voltage is going down, the voltage is going down. Now the Mercury Vapour light's tripped out at about 140 volts. You can see even at 120 volts the LED light's still running. So under brownout conditions, which is when the voltage dips, the LED will continue to power through. Now I'll turn the LED completely off. I've turned them completely off now, and now what we will do, we will bring the voltage back on. I'll turn the voltage back on at 240. So we're going to turn the voltage back on now. You'll see the voltage now is 240. We're turning back on now. LED comes on immediately. The Mercury Vapour light won't strike. It won't strike because the lamp has to wait till it cools down to allow it for the arc to restrike, and then you'll go through that continual warm-up procedure like we did before. And that's the explanation of the difference of the performance. So under brownout conditions and blackout conditions, this has significant disadvantages. This light will actually maintain operation even when the volts go down to as low as less than probably around about 100 volts, and it'll still work. Less than 100 volts, this light will drop out. This light drops out at around about 145 volts. Okay.